All right. So we just finished talking about how, depending on the level of confidence, 90%, 99%, 1.96%, then the thing that changes is right here. And this piece right here is called Z alpha over 2. All right, so let's put it all together. It's a lot to take in. All right. Hang on that piece. I want to explain like being 90% confident, being 95% confident, and being 99% confident. All right, so if I'm 90% confident I'm going to be right, then that means there's 10% of it I could be wrong. There's like a 10% chance I could be wrong. If I'm 95% confident I'm right, then there's a 5% chance I'm going to be wrong, like 100 minus 95. If I'm 99% confident that I'm going to be right, then there's a 1% chance I'm going to be wrong. Just FYI, 95 is pretty much like the standard. We're going to do all three percentages because different fields of study, like in medicine, you do 90-95. In science, you do 95 and 99. In education, you do 80, 90, or 95. So it just depends like on your field of study. And so I want you to be able to find all three, because these are the ones most commonly used. All right, so this is our formula. I would write it down. You could also do it like this. This way is the margin of error way. This one right here is the interval way. I'm just reviewing. This piece is called the margin of error. Okay, and the margin of error is the maximum likely difference between the parameter, like what we estimate the parameter to be, and the actual parameter. So if we're, if the president has a 65% approval rating and it's within 3 percentages, that means that 3% is the maximum likely difference between what reality is. All right, so this is pretty much like I have this written down and I keep it nearby. Because what changes is, in this formula, this piece. And so when we're given the confidence interval, we just stick the appropriate number in, and then they'll tell us the mean, they'll tell us the standard deviation, they'll tell us the n. They'll tell us all of that, we just plug it in. Little frog in my throat. All right, so right now, this data from example 1 was this guy right here, which is why I put it in list 1, because we might need it again. All right, and all I want to do is find the margin of error. All right, so according to our thing, for 95%, that's 1.96 for Z alpha over 2. So I'm going to do 1.96 parentheses. All right, there were 40 of them, so that's N. This is Z alpha over 2, and then I need my standard deviation. So my standard deviation, I'm going to go look. All right, standard deviation is, hang on guys, that one right there, sigma, so it's 57.9. We're not going to use the sample. All right, and so I'm going to put this 57.9 in. All right, so then I'm going to do 57.9 divided by square root 40. And then I'm going to do times 0.196. And I get 17.9. That's my standard, that's my margin of error. So 17.9 friends. That's kind of big. Alright, so we're going to do the same thing because I want to show you a couple of things. And this is, oh, look, we're silly. They told us. Alright, so let's go back. Erase that piece. Erase that piece. If I gave you a set of data, I would not give you that piece because I would expect you to be able to find it, just so you know. Alright, 53. Alright, so let's try this again. 53 divided by square root 40 times 1.96, and it's 16.4. Alright, so 95%, it'll be with give or take 16.4 friends. Alright, we're going to kind of remember that. Are we going to do the same thing? Sorry. And my TV's on, y'all. I'm just ridiculous today. Okay. For here, 99% is 2.58. 53 was our standard deviation, and there were 40 things. So I'm going to do the exact same thing. I'm going to do 53 divided by square root 40, my calculator, 2.58, 7.9 times 2.58. I get 20.4. So that's my error now. Notice when I went up in my confidence, my margin also got wider. Okay. Also, if you do this by hand, y'all, I don't know what my deal is. It's like 7:30 on a Saturday because I love you and I'm making you some videos. All right. Notice that so we went up on confidence. That means our margin's going to get wider. Here, our thing was 95 and it was 16.4. All right. So if we have 90%, which is 1.65 as d alpha over 2, and we're going to use 53 square root 40. You think it's going to be higher or lower? I think it's going to, that one's 20 and 16. I think it's going to be lower, but let's double check. All right, 53 divided by square root 40, 1.65 times 8.3. Oh, that's what I was going to tell y'all. Yeah. 13.7. All right, so what I was going to tell you was that if you do it like in the calculator, or if you do it by hand, or there's a function that'll do all of this stuff for the calculator, and I'll show you soon, you might be a little off. So maybe you got 13.56, or maybe you got 13.8. It's fine. Like, as long as for this answer, like you didn't get 14.9. Like, as long as you were within a tenth, a hundredth, it's going to be okay. I care more so about the process. All right, so let's review. Okay, this is when we know the population standard deviation. The population standard deviation is sigma. He's right here. And we know how many are in the sample. That's n. Then 1.65, 1.96, 2.58. I used 5.3 somewhere. Okay, 2.58 somewhere. 5.58. Okay, there must be a typo somewhere else. Maybe I fixed it. So those numbers go here, depending on whatever that confidence interval is, and they're going to give us this value. And we use that value to estimate the population one. All right, so sometimes I'm going to ask it for as a confidence interval, and sometimes I'm going to ask you to write it as a margin of error. And don't forget that this piece, that's called the margin of error. So maybe you just need to find that piece of it. Right, it's a really good. Right, so when we know the mean, the sample is random and it's greater than 30, or if it's less than 30, it's oh, always we're still rounding to one more less. So like here, it was whole numbers, so we need to go to 10. All right, let's do this problem. So we're still working in this problem with this data because I want to show you something else. Okay, so we're going to do 95% confidence interval in our formula. So my go-to is to write the formula, then figure out what all the numbers are that go into the formula, and then fill it out. All right, so x bar, that's our average, z alpha over 2, 95%, so it'll be 1.96. Sigma, we're going to use that 53. And n, there's 40. All right, when we did this guy for here, we got 125.3. All right, we just plug it in. Plug it in, plug it in. All right, x bar, 125.3 minus 1.96 parentheses 53 over square root 40. Do it again on this side. 125.3 plus 1.96 53 over square root n. We know n, it's 40. All right, so I do this piece first, and then I put it together. All right, so I'm going to do 53 divided by square root 40. I get 8.3, 8 times 1.96. So I get 125.3 minus 16.4. All right, then I'm going to do 125.3 minus 16.4 and 125.3 plus 16.4. All right, so I get 108.9, 141.7. I can write it like that as an interval, or I could write it as 125.3, give or take 16.4. All right, so I am 95% confident that the number of friends for an individual person would be between 108.9 and 141.7. Or I could say, I'm 95% confident that the number of friends will be 125.3, give or take 16.4 friends. And so that's how you interpret those results. All right. In the next video, I'm going to go over some more problems.